Imagine a superhighway inside your body, a vast network carrying vital information. Within each of us lies a nerve so extensive that ancient anatomists named it the wanderer, the vagus nerve. It begins in the brainstem, controlling our most basic functions. The vagus nerve embarks on a grand tour, wandering downward through our internal organs. It's a vital link between our brain and body, connecting our conscious thoughts to the unconscious world within. The vagus nerve is a key player in the parasympathetic nervous system, the body's rest and digest system. It is the great moderator, ensuring our internal systems work in harmony. Its influence is immense, a silent guardian of our inner tranquility. Let's take a step back and, consider the scale of this. The human body is a universe. It contains trillions of cells, all working together. And to coordinate this massive, bustling civilization of cells, we need communication. We need information to travel quickly and accurately across vast distances. The nervous system is our body's internet, and the vagus nerve is one of its most important, high-capacity fiber optic cables. It connects the central command center, the brain, to distant outposts in the chest and the abdomen, ensuring everyone is on the same page. Think about what it controls. The vagus nerve helps manage your heart rate. It ensures your lungs breathe at a steady pace. It tells your stomach and intestines to digest your last meal, breaking it down and extracting the energy you need to live, to think, to explore. These are not small tasks. They are the fundamental processes of life itself. Without the constant, vigilant oversight of the vagus nerve, this internal harmony would collapse into chaos. It is the unsung hero working tirelessly behind the scenes, a master of autonomic or involuntary control. This nerve is more than just a bundle of wires, it's a two-way street. It doesn't just send commands from the brain outward, it also carries a massive stream of sensory data back to the brain. In fact, about 80% of the vagus nerve's fibers are sensory. They are the body's internal reporters, constantly sending updates on the state of your organs. Is your stomach full? Are your lungs expanding properly? Is there inflammation in your gut? The vagus nerve tells the brain all of this and more. It is the source of our gut feelings, a very real biological connection between our belly and our brain. This incredible system highlights a pretty profound truth about ourselves. We are not just a mind controlling a machine, we are a fully integrated system. Our mental state can affect our physical health, and our physical health can profoundly impact our mood and thoughts. The vagus nerve is the physical embodiment of this mind-body connection. Understanding this wandering nerve is not just an anatomy lesson. It is a journey into understanding what it means to be human, to be a living, feeling, thinking being, a complete and interconnected universe unto ourselves. So, how do we begin to understand something so complex? We follow its path. We become explorers. In our journey together, we will trace the vagus nerve from its very beginning. We will venture into the brainstem, the control room where it is born from specific clusters of neurons called nuclei. Each nucleus has a distinct job, a unique contribution to the nerve's overall function. We will see how this intricate design allows the vagus nerve to manage so many different tasks simultaneously, from speaking to digesting to regulating our heart. From the brain, our expedition will follow the nerve as it exits the skull through a small opening, the jugular foramen. We will travel down the neck, navigating the crowded highway of the carotid sheath, where the vagus nerve runs alongside the major blood vessels that supply our brain. Here, we will discover its first major branches, the nerves that control the muscles of our throat and voice box, the very instruments that allow us to communicate our thoughts and feelings to the world. We will learn how a single nerve can give us the power of speech. Our journey will not stop there. We will follow the vagus nerve as it enters the chest cavity, the thorax. Here its path splits, with the right and left vagus nerves taking slightly different routes around the great vessels of the heart. We will see how it gives off critical branches that form complex networks or plexuses that wrap around the heart, lungs, and esophagus. It is here that the vagus nerve acts as the master regulator of our cardiorespiratory system, a constant presence ensuring our heart and lungs work in perfect, life-sustaining harmony. Finally, we will follow this wanderer to its ultimate destinations deep within the abdomen. Passing through the diaphragm, it spreads out to innervate a stunning array of organs. The stomach, the liver, the pancreas, the intestines, all receive their marching orders from this incredible nerve. It is a story of anatomy, yes, but it is also a story of function, of connection, and of life itself. So prepare for an expedition into inner space. let us begin our exploration of the anatomy of the vagus nerve, the wanderer within. Our journey begins in the most ancient and fundamental part of our brain. Long before complex thought, we needed a system to simply keep us alive. This control center is the brainstem, and tucked within, the medulla oblongata, is where the vagus nerve is born. This is a sophisticated command hub, made up of distinct clusters of neurons, each with a specialized role. Think of it as mission control maintaining life and balance within the body. It is the critical relay station between the brain and the spinal cord. It autonomously manages the most vital functions. Your heartbeat, the rhythm of your breathing, your blood pressure, all are regulated here. It is in this life-sustaining environment that the vagus nerve awakens. These points of origin are known as nuclei, each one a processing center for a specific type of information. The vagus nerve draws its fibers from 3 major nuclei, each contributing a different type of signal. This tripartite origin is the secret to the vagus nerve's versatility. It is what allows it to be a master communicator. It can simultaneously tell the heart to slow down, instruct the muscles of the larynx, and listen to the stomach. By understanding these 3 distinct nuclei, we can begin to unravel the mystery of this wandering nerve. The dorsal motor nucleus of the vagus nerve is the primary source of parasympathetic fibers. These fibers carry rest and digest signals from the brain to internal organs. This nucleus maintains peace, promotes tranquility, and conserves energy. It's essential for digestion and nutrient absorption. Commands travel down the vagus nerve to smooth muscles and glands, slowing the heart and promoting calm breathing. It's the body's natural brake, balancing the fight or flight response and overseeing digestion. This nucleus is a tireless force for well-being, ensuring the inner universe runs smoothly. Our next stop, the nucleus ambiguus. This nucleus controls the voluntary muscles of our pharynx, or throat, and larynx, or voice box. It directs our voice and ability to swallow, giving us command over our interactions. The instructions for this intricate muscular dance originate in the nucleus ambiguus. The nucleus ambiguus is also critical for swallowing. The nucleus ambiguus orchestrates this entire performance flawlessly. The nucleus ambiguus gives the vagus nerve its voice, its power to act on the world. Our final stop in the brainstem is the solitary nucleus, the brain's primary receiver of sensory information from the vagus nerve. It's not a command center but a hub that gathers real-time updates from our organs, gut, and even our sense of taste. Here, blood pressure, stomach stretch, and lung expansion data all converge, giving the brain a live status report on our internal state. This nucleus doesn't just collect data, it helps regulate responses like signaling the heart to slow down if blood pressure rises or generating the feeling of fullness after a meal. It's the physical link in the gut-brain axis, showing how our mind and body are deeply connected. The solitary nucleus is proof our internal world shapes our emotions, health, and sense of self. Assembled in the brainstem, the vagus nerve exits the skull through the jugular foramen, a busy intersection shared with other nerves and the jugular vein. Just outside it forms 2 small ganglia, sensory hubs for incoming information. Even at this early stage, the vagus sends out its first branch, the auricular nerve, which explains the ear cough reflex. This marks the nerve's transition from the brain's control center to the body's communication superhighway. Now in the neck, it's ready to navigate a crowded landscape of vessels and muscles, already influencing sensation and reflexes. The vagus nerve's journey has officially begun. Once free from the skull, the vagus nerve joins the carotid sheath, a protective bundle with the carotid artery and jugular vein. Nestled between these vessels, the nerve is shielded as it travels down the neck. Its position is strategic, allowing it to monitor and influence cardiovascular function. The vagus is a silent passenger here, carrying vital signals without fanfare. As it descends, it prepares to branch out to the throat and voice box, ready to control swallowing and speech. The neck is more than a passage, it's a launch pad for the vagus nerve's essential functions. In the upper neck, the vagus nerve sends out pharyngeal branches to form the pharyngeal plexus, the command center for swallowing. These nerves coordinate the muscles that move food safely to the esophagus and control the soft palate for both eating and speaking. The system is precise, a single misstep could cause choking. Sensory fibers here trigger the gag reflex, protecting the airway. The vagus nerve powers swallowing, shapes speech, and provides crucial sensory feedback. It's the master controller of the throat. The vagus nerve gives off the laryngeal nerves, which control the larynx, our voice box. The superior laryngeal nerve splits. Its internal branch senses threats above the vocal cords, triggering a cough to protect the airway. Its external branch controls pitch by tensing the vocal cords. The recurrent laryngeal nerve with its unique path controls all other laryngeal muscles for breathing and speaking. Together, these branches give the vagus nerve total command over voice and airway protection. Every note, cough, and breath is orchestrated by this system. In the neck, the vagus nerve truly finds its voice. Leaving the neck, the vagus nerve enters the chest, home to the heart and lungs. Here, its right and left branches take different routes, shaped by our body's development. The vagus forms intricate plexuses over the heart, lungs, and esophagus, blending with sympathetic nerves to balance organ function. Its main role now, to calm and regulate fine-tuning heart rate and breathing. The vagus doesn't create the rhythm of life, but it modulates it, connecting our physiology to our emotions. In the thorax, the vagus nerve becomes the silent conductor of our most vital functions. Let's follow the right vagus nerve as it enters the thoracic cavity. As it passes the right subclavian artery, it sends off the right recurrent laryngeal nerve. This nerve loops under the artery and ascends back to the larynx, the voice box, controlling most of the muscles that move the vocal cords for speech and breathing. This looping path is a remnant of our embryonic development. This makes the nerve vulnerable to injury, leading to vocal cord paralysis. The main vagus nerve continues down, contributing to the pulmonary plexus and esophageal nerve network. It continues as a master regulator, leaving the recurrent laryngeal nerve to control our voice. Now let us turn our attention to the left vagus nerve. Like its counterpart on the right, it descends from the neck into the thorax, but its path is distinctly different. The left vagus nerve crosses over the aortic arch. Just like the right side, the left vagus nerve also gives off a recurrent laryngeal nerve. Because it is lower down in the chest, the left recurrent laryngeal nerve has a much longer detour, looping underneath the arch of the aorta itself. This longer path means the left recurrent laryngeal nerve is susceptible to damage from thoracic problems. It then makes its way to the esophagus, ready to join its partner from the right side. The different paths taken by the right and left nerves are a profound lesson in anatomy. As the right and left vagus nerves descend past the great vessels and the roots of the lungs, they do not simply remain as two distinct cables. They begin to branch out, sending countless fine fibers that intermingle with each other and with fibers from the sympathetic nervous system. This creates vast, web-like networks of nerves known as plexuses. These are not simple junctions but complex communication hubs that wrap around our vital organs, providing a nuanced and balanced system of control. The most prominent of these in the thorax are the cardiac plexus and the pulmonary plexus, the command centers for the heart and lungs. First, let's look at the cardiac plexus, which lies on the surface of the heart, particularly around the base of the great vessels. Both the right and left vagus nerves contribute parasympathetic fibers to this network. These are the braking signals. When the vagus nerve fires, it releases a neurotransmitter called acetylcholine, which acts to slow the heart rate, reduce the force of contractions, and decrease blood pressure. This is the nerve's rest and digest function in its purest form, providing the calming influence that conserves the heart's energy and allows it to fill more effectively between beats. It is the gentle hand that steadies our most vital pump. Simultaneously, the vagus nerves contribute to the pulmonary plexus, a similar network that surrounds the major airways, the bronchi. The parasympathetic signals sent to this plexus have two main effects. First, they cause the smooth muscle in the walls of the bronchi to contract, a process called bronchoconstriction. This is a normal function that helps regulate airflow in a state of rest. Second, they stimulate the glands in the airways to produce mucus. This delicate balance ensures our airways are protected and lubricated without being obstructed, a constant, unconscious adjustment managed by the wandering nerve. These plexuses are a perfect example of the body's principle of dual innervation. Here, the calming, parasympathetic fibers of the vagus nerve work in direct opposition to the activating fight-or-flight signals from the sympathetic nerves. This dynamic antagonism allows for precise, moment-to-moment regulation of our heart rate and breathing. It is not an on-off switch but a finely tuned dimmer, constantly adjusting to meet the body's changing demands, whether we are sleeping peacefully or climbing a flight of stairs. The vagus nerve, through these intricate webs, is the master of moderation in the thoracic realm. After contributing to the networks for the heart and lungs, the right and left vagus nerves converge on their final major structure within the thorax, The esophagus. This muscular tube is the conduit that carries food from our throat down to our stomach, and its function is far more complex than a simple pipe. It must propel food downward with coordinated wave-like muscular contractions, a process known as peristalsis. The vagus nerve is the primary conductor of this essential performance, ensuring that our food reaches its destination efficiently and safely, a journey that begins the moment we swallow. As the two vagus nerves approach the esophagus, they once again form a plexus. This esophageal plexus is a dense network of nerve fibers that coats the outside of the tube. The left and right vagus nerves lose their distinct identities here, their fibers intermingling freely as they wrap around the esophagus. This network provides the motor commands that orchestrate the rhythmic, sequential squeezing of the esophageal muscles. It is a top-down wave of contraction that is entirely involuntary, a silent, powerful force pushing sustenance toward the stomach, a process we are completely unaware of until it goes wrong. As the plexus travels down the lower part of the esophagus, nearing the diaphragm, its fibers begin to coalesce and reorganize. The scattered web of nerves starts to bundle together again, but not into the original right and left nerves. Instead, they reform into two new trunks. Generally, the fibers that came from the left vagus nerve tend to rotate towards the front of the esophagus, forming the anterior vagal trunk. The fibers that came from the right vagus nerve tend to rotate towards the back, forming the posterior vagal trunk. This reorganization is the final act of the vagus nerve in the thorax. This transformation is crucial, as these newly formed anterior and posterior vagal trunks are what will pass through the diaphragm alongside the esophagus. They are preparing to enter the final frontier of their journey, the abdomen. The thorax has been a place of divergence, of looping paths and web-like plexuses. It is where the vagus nerve has tamed the heart and lungs. Now, as it reforms into two consolidated trunks, it is poised to deliver its parasympathetic commands to the vast and complex world of our digestive organs, carrying the rest and digest message to its ultimate destination. Our wandering nerve reaches the diaphragm, the dome-shaped muscle separating the chest from the abdomen. The vagus nerve travels with the esophagus through the esophageal hiatus. Leaving the heart and lungs, it enters the world of digestion. The vagus nerve fibers reorganize. The left becomes the anterior vagal trunk and the right, the posterior. Poised to deliver parasympathetic commands to abdominal organs, this is the final act of the rest and digest system. The vagus nerve communicates with nearly all the abdominal organs, signaling when to release digestive juices, when to churn and mix, and when to move contents along the production line. It is here that the vagus nerve truly lives up to its name, the wanderer. The anterior vagal trunk, born from the left vagus nerve, enters the abdomen. It primarily influences the upper digestive tract, signaling the stomach to produce acid and enzymes for protein breakdown. This initiates stomach churning to mix food into chyme. It's the go signal for digestion, triggered even by the thought or smell of food. The hepatic branch extends to the liver and gallbladder, regulating metabolic functions and bile release for fat digestion. As food enters the small intestine, the anterior vagal trunk ensures the liver and gallbladder are ready to continue digestion. It acts as the foreman, coordinating the upper digestive system. While the anterior trunk manages the front line of digestion, the posterior vagal trunk, formed mainly from the right vagus nerve, takes on a broader and deeper role. After passing through the diaphragm, it also gives branches to the stomach, covering its posterior surface and contributing to acid secretion and motility. It sends out the celiac branch, which travels to the celiac plexus, a grand central station for autonomic nerves in the abdomen. Through the celiac plexus, the posterior vagal trunk extends its parasympathetic influence to the pancreas and small intestine, promoting peristalsis. The posterior trunk is the great motivator of the entire intestinal tract, ensuring the efficient absorption of nutrients. This single nerve trunk is responsible for managing the core digestive and metabolic processes happening deep within our abdomen. The journey into the abdomen is not a one-way street. 4/5 of the nerve fibers in the abdomen are sensory, collecting information from our internal organs and sending it back up to the brain. This forms the physical basis of the gut-brain axis. The gut reports pretty much everything. This gut-brain conversation impacts our mood and well-being. Inflammation or distress in the gut can send signals that the brain interprets as anxiety, stress, or even depression. This is the biological reality behind our gut feelings. Understanding this two-way communication is revolutionizing medicine. Maintaining a healthy gut microbiome might be crucial for maintaining mental health. The vagus nerve is the essential bridge between our two brains. The vagus nerve's grand tour, which began in the brainstem, must eventually come to an end in the colon. Specifically, the vagus nerve innervates the ascending colon and the majority of the transverse colon. This boundary is often marked by a point near the splenic flexure. Here, the wanderer's journey concludes, providing its final parasympathetic instructions, helping to control the motility of the first part of the large intestine. Beyond this point, parasympathetic control is handed off to the pelvic splanchnic nerves. The dividing line corresponds to the division between the embryonic midgut and hindgut. Our adult anatomy is a living map of our developmental origins. And so, our journey following this incredible nerve to its final whisper in the colon comes to a close. We have traveled the path of the vagus nerve. Our expedition began in the medulla oblongata, its triple origin giving it diverse powers. It's a master of autonomic calm, a controller of voice and throat muscles, and a listener, gathering intelligence from our inner world. In the thorax, it transforms into plexuses over the heart and lungs. Finally, we crossed into the abdomen. The nerve unleashes its rest and digest protocol, commanding the stomach, liver, pancreas, and intestines. The vagus nerve is a two-way conversation between our gut and brain, shaping our mood and feelings. It's a wandering path that ties our entire being together. The vagus nerve is the king of the parasympathetic nervous system. It is the architect of our inner calm. In a world filled with stress, the vagus nerve provides the essential opposing force. It slows our heart, deepens our breath, and directs our resources toward renewal and repair. The vagus nerve is a master regulator of inflammation. This nerve is the physical bridge that connects our mind to our body, shaping our emotional landscape. Our physical health, emotional state, and mental clarity are all part of the same conversation. By appreciating the role of this unseen architect, we gain a new perspective on health. The story of the vagus nerve is far from over. In fact, we are just beginning to unlock its full potential. As our understanding grows, it is becoming one of the most exciting targets in modern medicine. Scientists are now exploring ways to directly communicate with this nerve to treat a wide range of diseases. This field, known as bioelectronic medicine, envisions a future with tiny implanted devices sending precise electrical signals to the vagus nerve, correcting imbalances and restoring health without traditional drugs. It is a new frontier of healing from within. One of the most established applications is vagus nerve stimulation, or VNS. Originally approved for treating epilepsy, VNS involves implanting a small device like a pacemaker that sends mild electrical pulses to the vagus nerve. It has since been approved for treatment-resistant depression and is being investigated for rheumatoid arthritis, inflammatory bowel disease, and heart failure. By hacking into the body's own neural circuits, VNS can rebalance the nervous system, reduce inflammation, and restore normal function, offering hope where other treatments have failed. The future holds even more promise, with non-invasive methods gaining traction. Devices that stimulate the nerve through the skin, particularly at the ear where the auricular branch resides, are becoming available. This transcutaneous VNS offers influence without surgery, making these therapies accessible to many more people. Imagine a future where we can manage stress, improve mood, or reduce inflammation by simply applying a small device for minutes each day. This is the tangible promise from our exploration of anatomical pathways. Our journey through the anatomy of the vagus nerve has taken us from the brainstem to the colon, revealing breathtaking complexity and elegance. It is more than a bundle of fibers, it is a communication network, a bringer of balance, and a bridge between mind and body. As we continue to explore this inner space, we are uncovering new ways to heal, to thrive, and to better understand the universe within us. The wandering nerve still has many secrets to reveal, and its story is humanity's story, a continuous journey of discovery into life itself.